We're going to continue with hypothesis testing and example number 3. Before we get to example number 3, let's take a look at that procedure table so that we can review what we have been doing. So we have been working on the traditional method here. So we've been working on that traditional method, and with that traditional method, we've been going through a really consistent 5-step process. We've been going through the hypotheses, with our null hypothesis having the equal sign always, and we've been doing a test of the mean for all of these. So we've got a population mean in the null hypothesis. The alternative hypothesis also has a population mean, but that inequality symbol could be equals, or sorry, not equals, less than, or greater than. The symbol that we use in the alternative hypothesis determines the type of test, whether it's one tail or two. The not equal sign splits the tail into 2 regions. The less than symbol, think of that as an arrow, and it's going to point to a tail on the left. So we've got a rejection tail there on the left. And then this greater than symbol, again, I think of that as an arrow pointing to the rejection region, and that's going to be a tail on the right. Regardless of your setup, anywhere in the middle, we're going to make a decision that would be fail to reject the null hypothesis. It's like we're keeping the null hypothesis. Our hypothesized mean here is in the middle. Anything that lands in the rejection regions, whether it's 2 tail or 1 tail, means that we're significantly different. So anything in these rejection regions, we would reject the null hypothesis. So we've got some really consistent steps regardless of that alternative hypothesis. For the critical value, we use table F. For the test value, we're using our calculator, which makes it nice. And then we make the decision to either fail to reject, virtually keeping the null hypothesis, or if we reject the null hypothesis. All right, so there's our summary. Let's get back to it with example number 3. So in example number 3, we're testing some M&M weights. We've got a sample of 19 green M&Ms. So there's my sample size, n is equal to 19. And the sample resulted in a mean of, so this would be my sample mean, 0.8635 grams. Assume a population standard deviation. So I've got sigma here, 0.0565 grams. So we know, because we have a known population standard deviation, that we're going to be doing a z-test instead of a t-test. We also have the significance level. This is the size of our rejection region. So we're going to reserve 5% in the tail of the normal curve for the rejection region. And we want to test this claim that the weight of all green M&Ms, it sure sounds like a population mean, is equal to 0.8535. Okay, let's put this together in our 5-step process. Step number 1, we need a null hypothesis, and we need an alternative hypothesis. In this particular example, we were actually given that null hypothesis. We want to test the claim that the weight of all green M&Ms is equal to, so mu is equal to 0.8535. This is our claim in this case. Let me mark that in red. So this is our claim. As I continue with the alternative hypothesis, we're also going to use a mu here. We just need to choose from not equals, less than, or greater than. It's really tempting to look at the sample mean and say, oh, it must be greater than, but we really have to read the words carefully. Are we thinking that the mean is greater than? Do we think the mean is less than? None of that is stated in the words. We do have the sample result, but we're not trying to disprove with a greater than weight or a less than weight, which means that we're going to use this not equals. So it either is the 0.8535 or it isn't. This gives me a 2-tail test. Let me go ahead and draw my normal curve. I'll draw it over here. So I've got a 2-tail test. I'm going to split that 0.05, that 5% rejection region, into 2 tails. So each of these tails has an area of 0.05 divided by 2, 0.025. So if we land in either of these shaded areas, we'll reject. Otherwise, if we land in the middle here, we will fail to reject. that null hypothesis. So I continue to label this. My mean goes right here in the middle. So the mu of 0.8535 goes right in the middle. We want to know if this 0.8635 is significantly greater and lands here. We've got z-scores labeling this line underneath. The mean has a z-score of 0. We're going to figure out what that critical z-score is that cuts off the rejection region, and then we'll also find our test value. So we're ready for step number 2. Let's find the test value next. The test value is the z-score for the sample data. So we're going to find that z-score using the calculator. Just go ahead and grab the calculator. And we're going to put our values in to the calculator. Let's see if I can just move this out of the way a little bit. There we go. Let me hit quit and then go into the stat menu, over to tests, and I'm looking now for the z-test of the mean. I don't have data, I don't have individual data values, but I do have stats, so stats is highlighted. It's prompting me for the hypothesized mean. That's my 0.8535, right from that null hypothesis. My, oh great, it's already here. So my standard deviation for the population is 0.0565. Sample mean, perfect, 0.8635, 19 is n, and then I'm looking at my alternative hypothesis for this second mu, and that's going to be not equals. Great. So I'm going to go ahead and hit calculate to come up with that test value. So my test value is the 0.7715. So 0.7715. Let me get rid of this. So 0.7715. It is positive, so I know it's going to land over here somewhere. I'm just not sure exactly where. Let's go ahead and do step number 3. Step number 3 is my critical z-value. I'm going to find my critical z-value on table F. Whoops, table F. To tail, let's see, what else do I need to know? I need to know the significance level. They're not all 0.05, but these happen to be 0.05, and I'm looking for a z-score. Let's go ahead and switch over to table F. So with table F, we are now looking at two tails here. So I'm going to use the second column using two tails. And we are at 0.05 with my two-tail test. So I'm going to be right there in the middle row. My n doesn't matter because I'm looking for a z-score. Everything underneath the degrees of freedom, these are all t values. So I need to scroll all the way to the bottom. My z-scores are the bottom row there. Everything else, all of these are t values. So I'm going to go ahead and use the z-scores here at the very bottom. See, I was in that middle 0.05 row, so that's going to give me critical values of 0.196. And as I look over here, I do have two tails, so I'm going to label that as a negative and a positive. It gives me both of those. So 1.96, let me switch back over to our example. So my critical z-values, because it's a two-tailed test, I put a plus or minus in front of it, and it's 1.96. Okay, let's go ahead and label my normal curve here. I'm going to grab my red pen. My critical value right here and here, this is what cuts off those rejection regions, negative 1.96 and positive 1.96. My test value of 0.7715, that one was positive, so it's going to live over here somewhere, 0.7715. It does not land in the rejection region. Instead, I stay in the close to my sample or my population mean, my hypothesized mean that failed to reject. Let me go back to my black pen. Step number 4. Reject or fail to reject. We did not land in a rejection region, so we failed to reject the null hypothesis. Step number 5 is my summary. So step number 5 is my summary. Just need to answer that question. We are testing the claim that the mean weight of all green M&Ms is 0.8535. Well, we conducted our own sample, and we found that our sample mean of 0.8635 had a z-score that was pretty darn close to 0. So we say that we actually support that claim. So we support the claim that the mean weight is 0.8535. And if I take a look at my hypotheses, my null hypothesis was the claim. So that's kind of a nice way to put it all together there, to be able to tie your summary to your hypotheses. Your claim is sometimes the null hypothesis. The majority of the time it's the alternative hypothesis, but in this case it was the null hypothesis. Okay, all 5 of our steps are there. Again, a really, really nice, consistent process. All right, so example number 4. So the health of a bear population in Yellowstone is monitored by taking periodic measurements. A sample of 54 bears, there's n, so n is equal to 54, has a mean, this is our sample mean, so that's my x bar, of 182.9 pounds. Whoops, 182.9, let me just fix that. Okay, so 182.9 pounds, this is our sample mean. And a standard deviation. This is for our sample. So this standard deviation here is a sample standard deviation. So we're going to label that guy S 121.8, which means that we do not have a known population standard deviation. So we are going to be using a t-test. We've got some more information, another 0.05 significance level. Okay, so we're going to stick with that 0.05 significance level, and we're going to test the claim. So here's our claim that the population is greater than. Okay, this right here, that the population's mean is greater than 150. So what they gave us with this claim is the alternative hypothesis. So let me put my hypotheses together right here. We have the null hypothesis and the alternative hypothesis. In this case, our claim is that the weight is greater than. So mu is greater than 150. This is our claim. Let me mark that in red. It really helps with that final summary step if you've identified that as you're putting your hypotheses together. The other one I've got to come up with is the null, but that one's easy. The null always has the equal sign in it. So the null is that it is equal to 150. I've got a greater than symbol. This gives me a one-tailed test. And you can think of that greater than symbol as an arrow pointing to the tail. So we've got a one-tailed test on the right. So it's going to look like this. Fail to reject in the middle. This is fail, and then reject if I land out here. My hypothesized mean is 150. That's mu. We're doing a t-test, so t values go here. So t is going to be equal to 0, and I'm going to have one critical t value that cuts off the rejection region. Okay, so kind of put it all together there in the curve. Let's go ahead and go into number 2. So for step number 2, let's find the test value. The test value is the one that's linked to your sample information. So I'm going to need the 182.9, my sample size of 54, and my sample standard deviation. I'm going to put those into my calculator. So let's go ahead and grab the calculator. I'm going to quit out of my last test. I'm going to go stat and then tests. I'm doing a t-test this time. So it should prompt me for S instead of sigma, and it does, which is great. Okay, so no stats, or sorry, I do have stats, no data. So I'm ready to type in my hypothesized mean. That is 150. X bar, my sample mean, is 182.9. Sample standard deviation 121.8. 54 is my sample size, and now I'm looking for my alternative hypothesis. This one is greater than, so I arrow over to greater than and hit enter, and then I calculate. It's going to give me that test value. So my test value is 1.9849. So t, my test value, is about 1.9849. 9. Okay, so we'll leave it at that. Let's go ahead and hide the calculator. I'm ready, step number 3, to come up with my critical t. So my critical t is going to come off of table F. I know that I need degrees of freedom. Degrees of freedom is 1 less than the sample size, so that's going to be 53. This is a one-tail test, and my standard deviation is 0.05. Okay, so let's grab table F. So in this time, table F, my n was 54, so my degrees of freedom is 53. So I am looking here because I'm looking for my t values. I don't have 53, so I'm always going to round up to the next one. So I'm going to grab 55 in this case. I had one tail and 0.05. So up at the top of my table, one tail 0.05 puts me into the second column here. So staying in the second column, using 55 this time, I think that's a 1.673 it looks like, 1.673. Back to our test. My critical value is 1.673. Remember, it doesn't give you positives or negatives, so I look back at my chart, and it is over here on the positive side. So I don't need to worry about a positive or a negative, but I can label this one now as 1.673. When I go to put my test value in of 1.98, it's going to be just on the other side of 1.673. So I am going to land in the rejection region for this one. So step number 4, I'm going to reject the null hypothesis. And then finally, step number 5, I need to summarize this. So first of all, we did find that the mean weight is significantly larger. So we found that the mean weight of these bears is significantly, I'm just going to write SIG, larger than the 150. How does this relate to our claim? So if I move back up here, oh, it's already there. My claim is the alternative hypothesis. So in this case, my test does support the claim. So supports the claim. Okay, and that's all there is to that. So there's those same very consistent 5 steps.